So once you find the answer, start jotting down some notes. Okay, what is a possible solution to the system of inequalities shown? I'm going to try to make it as big as possible, but it'll still be pretty small. I'm not going to lie to you. So what is a possible solution to this system? What is a possible solution to this system of inequalities? What is a possible solution? Okay, so some of you did get it right, whether by chance or not, we'll see. Um, so systems of inequalities, how many are needed in a system? So that's why you could see, and I know it's hard to see, but there's too many linear inequalities over here. You can type them into Desmos. You'll have to put them in different like cells, but like type them into Desmos, you'll see a graph like this. But what you'll probably actually see is more shading than just what's shown. So let me show you what it looks like. Like you have Desmos on your final as well. All right, so greater than negative x plus 2. All right, so I have y greater than negative x minus 2. And then the other one, and the other one is less than negative 5x plus y less than negative 5x plus 2. I could be x and maybe x. So do you see how all of the buttons are easily accessible? I don't have to go anywhere special to find them. I'll get them next street. Lakeland, on vacation. You could look. You know, be looking at the screen. I'm giving you guys like really great tips right here. You should be taking notes as you go. I don't think you guys are really. All right, but compare this to what you saw when we saw it in the Kahoot. You don't see the extra shading for this one that you see in Desmos. You only see where it overlaps. Why? What did we learn about solutions to system of equations? Has to satisfy both. So eyes on my screen, please stop with everything else. I'm having a conversation. So solutions to systems of equations satisfy both equations. Solutions to systems of inequalities have to satisfy both inequalities. So if I just look at one of the inequalities, this red shaded area satisfies this one inequality. So let me say that the coordinate from that area. 0, 10 is that coordinate. See it? So if I plug in 0 for the x and 10 for the y, negative 0 minus 2 is negative 2. Is 10 greater than negative 2? Is that true? Yes, it is true. So that ordered pair satisfies that one inequality. The other one, and let me make up a different one than what I arrow want you to see. Let's do one with the equal to part. Right? So I just made a new system and data for inequality. If I look at just the green, anything in that green shaded area and on this solid line would satisfy the inequality. Okay, so like let me pick something that's on the solid lines. So like this one, the x is 1.5 and the y is 0. I would plug in the 1.5 for the x and 0 for the y. 2 times 1.5 is 3. 3 minus 3 is 0. Is 0 less than or equal to 0? Yes. 0 equals 0. So that's what less than or equal to means. It's supposed to be less than or equal to it, and that one is. See what happens if I change that symbol to without the little line underneath, without the. Okay, it turns into a dashed line. So if I do that, all that changes about it is the fact that there's a little line underneath it. Anyway, if I plug that in again, that same point, it was 1.5 times, it doesn't want me to do it. But what I would get, let's see one more time. Wait. Anyway, is 3 less than 3? No. So me taking away that equal to part makes it no longer make sense. So now anything that's on the dashed line is never a solution to the system. Okay, there we go. When I plugged in 1.5 into this, there actually no 0 for the y and 1.5 for the x. I get 0 less than 0, which is not true. That's why anything on the dashed line is not a solution to that inequality. Okay, everyone with me so far? So then when I have my system of inequalities, and I'm again making up just a random one to show you, anything that is a solution to the system is where the shading overlaps. It has to satisfy both. So in this case, this big, like darker area would be my solution, not this and not that. And definitely not this. That's not even the shading. And if it's on a solid line touching the shaded area, then it can be a solution so long as it's not on the dashed line. So never on a dashed line. All right, questions? So that's replacing the taking notes, so I hope you're getting it. You're still required to take notes on this. You're not as we go. The practice. So what's a possible solution to this system? Coordinate. The part. It's y less than or equal to 1/2 x plus 2 and y less than -2x times 2. Okay, so pulling up, it's already graphed for you, and this one is only showing you the overlapping shaded area, but just know like graphed with technology, you look for the area that's like shaded the darkest or overlaps. But for answers, you're just looking, and I know it's small, but you're looking to see if it's in the overlapping shaded area. So -2 is here. That's why that was our solution, because it's in the overlapping shaded area. 1, 1 is over here, so definitely not. 10, 1, I can't even see on my graph, but it would be like here-ish. And then that other one, let's see, 4, -1. That was, yeah. Oh, only the red option was in the overlapping shaded area. All right, what's the following inequality in slope-intercept form? So rewrite it into slope-intercept form. Similar to what we did earlier, put it in slope-intercept form. Okay, so similar to with the equations, if I say to put the inequality in slope-intercept form, what I mean is to get what alone? The y. So I know it's in slope-intercept form if the y is by itself. So looking at it, how do I get the y by itself? What do I get rid of? I get rid of the -2x by adding 2x, right? In order for it to go away, I need it to become 0. And then whatever you do on one side of the inequality, so you do on one side of the inequality. So that gets my y alone. On the right side are 5 and 2x like terms. So you cannot like make it 7x or something like that. We're just rewriting. And I like putting it in this order so it looks like mx plus b. The only thing that's different from what we did earlier is that it's an inequality. So sometimes that inequality flips. When does that inequality flip? When you multiply or divide a negative number on both sides. So unless that happens, just keep the sign in the direction of the space. All right, but yeah, so that is how you convert that. Right, sure, we're taking good notes as we go. I don't want like just questions and answers. Like there's certain details that we're talking about that I would want to see because we didn't put the action notes on this one at all. If there are notes for it. Okay, so convert this one into slope-intercept form. Put this one into slope-intercept form. put your answer in and take down some notes. Gianni, is this your paper I sent in? Without any money. One. It's very long. Okay, so we are converting this inequality into slope-intercept form. So that means isolate the y. Kyle, what do I need to get rid of first in order to isolate the y? What's farther from it, the 2 or the 4x? The 4x. I don't want to just get rid of the 4 because I want like the full term to go away. I want it to become 0 plus 2y. Jenny, how do I make the 4x become 0? Good. And then whatever we do on one side of the inequality, do to the other side. So I have 2y greater than, these are not like terms, one has an x, the other one doesn't. So it's going to be, and I like writing it where the x term is first, negative 4x plus 10. So the 10 is still positive, the 4x is still negative. And it's not fully isolated yet, so we have to keep going. Logan S, how do I get the y fully by itself? By just 2. I don't want the y to cancel out, I just want the 2. Okay. On the other side, we're going to divide the whole side by 2, which means each term individually by 2, because we'll have to reduce it. I don't need to flip the sign for that, because all I did was divide a positive, so that's, I don't need to flip it. Negative 4x divided by 2 is negative 2x. 10 divided by 2 is positive 5, which is the blue option. Good questions, comments? And that's if we are graphing it by hand. To be in slope-intercept form. Or just to see certain parts about it. Okay, how many solutions does this system of inequalities have? How many solutions does this system have? How many solutions is the question? Okay, almost 100% accuracy. So we talked about solutions for systems of inequalities is where? You should hopefully have it on your notes already for your little grid paper. It's where the shading overlaps. Do you see any overlapping shading? So this would be a situation, this would be a situation where it's no solution because it has parallel lines shaded in different directions. It is possible to have parallel lines here and there still be solutions, but like I could shade this way. And now I have an overlapping shaded area, but they're shading in opposite directions. So no solution. Good questions. Moving on. I don't think there will ever be just one solution to a system of inequalities, so there's lots of ordered pairs. Is 2, 3 a solution to this system? 2, 3. Okay. So glad no one picked, I don't know. So 2, 3 is here. This image is showing you just the overlapping shaded area is colored in. Sometimes they show like lightly colored other shaded areas. We only want the overlapping shaded areas to be first. So that's where 2, 3 is. Maybe we were confused by this one, but that was also a solution too. So, yeah. Like we were looking at the wrong dot. Oh, well, hopefully we know how to read it. Here's the X. X to the left. We go X to the left, Y to the sky. So be able to read the coordinate plane, to evaluate if it's a smooth. Okay. Next one. Inequality. So it's going to be an image. Which point satisfies that system? You are allowed to use technology. I mean, I didn't do graph papers. It's technology. Which point satisfies that system? Okay, so you could have gone about this 2 ways. You could have done that one thing I showed you where you're plugging in the X and Y into both inequalities and seeing which one makes them both true. I wouldn't necessarily do that because that would be time consuming. But if you graphed it, then all you really have to do is evaluate different points. So to graph it, you need in one cell, like this is what I mean by cell. Here's one cell, here's the other cell. In one cell, type the first inequality, so y less than 5. In the other one, type the other. And the buttons are easily accessible, like they're not hidden from you. You don't even have to put it into slope-intercept form if you're using technology. You can just do it exactly how they give it to you. And then you know anything in this quadrant, or well, not quadrant, but this overlapping shaded area is your answer. Now, another good thing that Desmos does is if you, in a different cell, type in your coordinates, it can also label it on your graph. So there's that. You could type them all in. You could just keep changing the one, but it only reads it if you type it in right. If you use the parentheses and the comma in between, this is the only one that's in the overlapping shaded area. Good questions. Okay, next one. All right, select the graph of the system of linear inequalities. I know it's hard to see, I'm sorry. So I'm going to zoom in, I'll rewrite it, but you're selecting the graph that matches the system. And the options match how they look on the screen. So it goes A, B, C, D for your options. And then for the inequalities, if you can't see this tiny writing, then I wrote it a bit bigger. Again, take a note. Like the easiest password grade you can get. That's 30% of your grade. Okay, so you're allowed to use technology, but there are certain things you can rule out based on some of the facts, but on your final, definitely use your technology to double check. So first, looking at my symbols, I know that these lines should both be solid or dashed. Both of them should be dashed because neither of them have that equal to part. So the dashed lines are what they should be for both. So any that has them as both solid or even just one of them solid need to go. So looking at my options, that rules out B and that rules out D. A and C is what I'm narrowing between, which the difference is the shading now. Both of these happen to be in slope-intercept form, so I can tell what the shading should be just from looking at it. I want to, for this one, shade where y is greater than. So you know how your y-axis goes up and down? When I go up, do the numbers get bigger or smaller? Bigger. When I go down, do the numbers get bigger or smaller? Are you guys listening? Easy question. When I go down on the y-axis, do the numbers get bigger or smaller? Well, let's look at the number line that's right here. As I go down on the y-axis, do the numbers get bigger or smaller? Okay. So I go up on the y-axis, they get bigger. Down, they get smaller. So if I want to shade above where the y is greater than -5, that would be above this line. So this is the line that has no slope, right? That's why I didn't have an X there. I would actually want to shade above the line, not below it, because this would be where the y's are greater than -5. So that rules out A then. That means it has to be Z. But for the other one, that one was y less than whatever's on that line. So that's where I would shade this side of it because that's where the y's are smaller. Questions? Okay, so then moving on to the next one. Okay, so select the graph of the system of linear inequalities. So same thing, different equations. I'm going to try to zoom in. The order is still A, B, C, D, like how it looks. You guys should be taking notes, so I should like shouldn't have to think too hard about this. If these are my symbols, should my lines be solid, dashed, or one and the other? Good. So any that has them as both solid or both dashed, I need to eliminate. So that means that B is not an option. I'll drop it off over here. Looks like D is not an option. And C is not an option either. So just from that alone, I've already narrowed it down to the right answer. Usually on your test, they try to be a little more difficult than that. They'll have you look at the shading as well. For the shading though, it would need to be in slope intercept form if I'm going to tell just by looking at it. So I can tell you like for this top one, when I rearrange it, I will be dividing a negative on both sides and that would flip it. So that's why on our solid line, we're shading above. But again, you can use technology. Many of you seem to know that for your final pre-test. So just keep doing that. Next one. All right, if I said your name earlier about the notes, you have 4 questions to get it together, or else I'm really convinced you just don't care about it. All right, so which one represents this inequality? And these are slightly off from the answers. When you pick your answers, it goes in this order, which does not match what you see here. Okay. So with this system, unfortunately, I can't eliminate any based off of like if it's solid or dashed because all of the options were correct for that. They all have solid lines. So that's not going to be what determines it. Luckily, these are in slope intercept form. So the shading I could tell just from looking at it. But again, you could use your technology and know for sure. If it's y greater than or equal to, James, if it's y greater than or equal to, do I shade above or below? Above. Because if I want y to be greater, well, when I go up on the y-axis, those values get greater, right? Kyle, if it's y less than or equal to, do I shade above or below? No, below. Because if I want y to be less than, when I go down on the y-axis is where the y's get less, don't they? So that's why it's shade below. Oh, I didn't hear. I thought you said above. As long as you know. So then look at the one that has a y-intercept of -2. This one needs to be shaded above. And so far for A, it is. Look at the one that has a y-intercept of 1. That's right here, this line. This one needs to be shaded below. And then where they overlap, which is right here, is my solution. All right, questions? All right. And then if the quiz wants to get really like tricky, they might have you really look at if the slope is right and if the y-intercept is right. So just make sure we can do that. Okay, this will probably be our last one. How many solutions does this system of linear equations or inequalities have? All right, too many. You see all these many different ordered pairs here? Even if when you think about like the decimals, that's a lot. There's too many to count. So congrats to everyone. If you had to turn in your phone, make sure you grab it. And if you were one of those people that I told you you need to take more notes or I'm giving you a 0,